Good morning, everybody. Hope you are very attentive is remote sensing classes. Not only these classes, but also all through the online sessions of various subjects. Coming to our subject perspective, this is the second week. That means all five sessions went on as part of this new week. That means second week of online sessions we entered. And in the past five classes, when we have a look, we discussed the introduction and we discussed basic primary steps, primary concepts of this subject. Primary in the sense, nothing but here in this perspective introduction part, where we discuss the topics like electromagnetic radiation, electromagnetic spectrum, interaction of electromagnetic radiation, the atmosphere, and also EMR interaction on Earth surfaces. Dear students, I told you and I keep on insisting you from the first session itself. If you have any doubts, you please contact me in the domain whatever you feel convenient. And this subject, while you are listening, it seems that you understand the concept. That's okay, nice, very good. But unless you are not revising what we discussed, you may not remember certain technical words by the time you are writing your examinations. Because the concept is new and there are certain new words like my scattering, resolution, spectral reflectance, spectral curves, and all, and many more in the days to come. Many more when we are moving forward the subject, when we are forwarding towards the subject. So have a look after one time, after following this video lecture one time, and whenever you have a time, and try to revise the things what we discussed in the previous topics. And probably when you have a look in the past week what went on with respect to all the subjects, you are more content and informative. And this and today's and I mean for today's session, we are going to discuss the followed topic. See, everywhere and every time I've been using the previous session slides also, so that whenever we come across to touch the previous topics, we are going back simply to the previous slides. Every time for every new session, we are adding new number of slides here. So whenever we have a need, we are going back and we are going back to discuss where we want and what we want. See here, in the past class, in the past session, in the previous session, we discussed regarding types of sensors and also characteristics of remote sensing. Now we are going to discuss a new topic, a new associated topic, that is types of remote sensing. In the previous case, we have seen the types of sensors. and we discuss the sensors are categorized into active sensors and passive sensors with respect to the energy what they require. Before we are going to discuss the types of remote sensing, I would like to brush up just what happened, what is what we discuss, and what is what about the topics we discuss. See, as you know that in almost a new number of students are adding into our Google Classrooms. Whoever understood, whoever understand the concept of remote sensing definition, that's okay. But still, if anyone newly joined, for them, I just want to give the definition one more time. Here, remote sensing means it is in a science and art of obtaining information of any object or any earth, of any object or any phenomenon, or as any area which is not in physical contact to it is called as remote sensing. It is a science and art of obtaining information of an object or an area without physically contact to it is called as remote sensing. There are basically 5 required components to conduct this remote sensing process. One is energy, the other one is target, third one is atmosphere or recording, and the fourth one transmission, and fifth one analysis, interpretation and analysis. Nothing but processing stations. Of course, interpreting different interpreting techniques. We may conclude like that. That also happens there itself in processing stations. And here coming to electromagnetic radiation, the only form of energy which senses or reacts, which the senses will react, for which the senses will react to perform the given task. See here electromagnetic radiation, and we know and we discuss almost 1 or 2, 3 times what is electromagnetic radiation, and followed by electromagnetic spectrum, and there after electromagnetic spectrum we have seen and we discussed regarding the interaction of atmosphere of EMR, how it is getting interacted. See here, this is about the scattering, and this is what happening while EMR propagates to hit the target, as well as it is reflecting back with the content of image, how it is going to be interact with the atmosphere. And scattering and absorption, both these two are the basic influencing factors of EMR in the atmosphere. And we have discussed already regarding the scattering. In the scattering, there are 2 types, selective scattering and non-selective scattering. In selective scattering, there are again 2 types, Rayleigh scattering and Mie scattering. And second one is non-selective scattering. Of course, after non-selective scattering, one of the other parameter that is showing its influence on EMR is nothing but absorption, where the energy is consuming. If the energy is absorbing instead of recording by sensors, the image of the target may not be complete. The resolution of the target will be dull. So absorption also one of the basic what we can is interfering factor of EMR, through which the image may get dull resolution, or else image may not be clear to interpret the analysis, to interpret the characteristics of the data. See here after the absorption, and what all the different reasons why Mie scattering and what happens in Rayleigh scattering and what happens in absorption, that was already we discussed. And we already discussed interaction of EMR with Earth surface, characteristics of remote sensing. And see here types of platforms. We are very close to the previous class. In the types of platforms, we have seen 3 types: ground level, air level, and space. After that, we are here. We are going to discuss today's topic, that is types of sensors. Here, types of sensors. Types of sensors. First of all, what is the need and what is the work of sensor in this remote sensing? What is the work of sensor in remote sensing? See here, sensors are recording energy as well as sending EMR to hit the target. That is the first step. And after hitting the target, by the energy which they produce into the atmosphere, if they are active sensors, the same energy has to be recorded by the sensors. After recording of the energy by the sensors, the same will be sent to the processing stations where the image will be processed. Now here, with respect to, see here, with respect to the energy, we have seen two types, active sensors and passive sensors. In the previous case and in the previous session, we have seen what is active and what is passive. Now here, types of remote sensing. This is our new topic, today's session. See here, two types of remote sensing. One is airborne remote sensing. The other one is spaceborne remote sensing. If you're born in India, you may be Indian. You are Indian, not maybe. You are. If you're born in India, you are Indian. If you're born in America, you are an American. See here, that means what I'm mentioning is here, airborne. See, there is a name, airborne diseases. Airborne diseases in the sense through air, the diseases will spread, airborne. Waterborne diseases. See, airborne diseases like influenza, okay, cold, all. Such type of diseases will spread through the contaminated air. See, waterborne diseases also there. In the previous semester, we discussed in E1 subject, first unit, there is a topic waterborne diseases. Because of the contaminated water, certain diseases will spread. Among them, hepatitis, that means jaundice. Here, it will transfer through contaminated water also. That cholera, sometime. All these are the waterborne diseases. See here, amoebiasis, all waterborne diseases. Now here, airborne and spaceborne remote sensing. See here, in the previous slide, we have seen active remote sensing and passive remote sensing. That is with respect to energy. Here it is with respect to the platform that is existed, where the sensor is existed. See here, airborne remote sensing. By the name itself, we are able to understand something that is being take place in the air. Airborne remote sensing. See, in the previous cases, we have seen in the here airplane in the air, by using cameras and videos, or else by keeping the cameras and videos to the helicopter or else aeroplanes, and number of cameras will be kept or else will be fixed to this airplane by covering all the sides. Because of that, the image, these airplanes may cover vast area, and the image may give the information from all the corners. What I am mentioning is here, when we have a look over here, what we discuss and what we are going to discuss. In airborne remote sensing, sensors are mounted on aircraft to obtain images of the Earth's surface. First point. See here, in which direction, downward or sideward? Airborne remote sensing, downward or sideward looking sensors. Depends on the situations. These sensors will take the images. I will capture the photographs, okay, and that may be useful to interpret the characteristics of the target or image. that is called as airborne remote sensing. See here in this image, the airborne remote sensing, by using the cameras, we are able to get the information about this particular locality. So to get, see here energy, see here how the cameras are taking the image by taking the energy of the sun. I told you, if you bought a nice iPhone or is whatever the phone based on your interest, against 1 lakh rupees, or is by spending 1 lakh or even more than 1 lakh, if you are unable to capture the images, sometimes the purpose may not be the you may not call this camera as a good worthwhile. I may not call this camera as a good one, even though, and you may feel that, sir, I may not use camera for anything else, but it is working. I love this. I mean, I'm very happy to to have this mobile phone because I never use, and there is no requirement for me camera. Then why you can call it is an useless camera? Of course, the purpose may be different to each other. At a most majority point of view, I'm speaking. The camera phone is one of the highly required option to majority of the people. If you are not using, that's okay. It's up to you whether you wish to have that phone and you wish to buy the phone 1 lakh or 2 lakh. It's okay. It's up to you. But in the society, there are two words: to accept anything for research, the majority and minority issues must be considered. Okay, if it is a majority point of view with respect to the influencing factor in the society, that can take up as an evidence to move forward in the research, to move forward to identify the problem of your research. What I'm speaking is here, if you are in a videographer, if anyone is a videographer, he bought a phone with respect to 1 lakh, if his camera is not working, whatever the amount of money spent, that is useless. Right. Coming to our normal, common, exemplary point of view, with your phone, you are trying to take an image of particular so and so person, and the only drawback is your phone is not having flashlight. Still, you can get the image of so and so thing or so and so person during daytime without any difficulty or without any lagging. But you cannot do the same during the night time because your phone has no capacity to capture the image. Even the atmosphere light also not available here to get the energy what your phone is required. See here, for here, when you have a look on, oh, look when you have a look in this image, the cameras are fixed both sideward or downward based on the requirement, based on the position that we want. Uh, the energy that is required is taken from the atmosphere. That's what this image meaning. And the information of this particular locality is being captured, and the same will be given for the interpretation of image. What is remote sensing? It is in the science and art of obtaining information of any object without physically contact to it is called as remote sensing. See, we are not in contact to this particular locality, but by using cameras which are fixed to the aeroplanes, we are able to retrieve, we are able to get the information. So this is about airborne remote sensing. Hope you know, understood. Followed by, we see here, what are the advantages here? See here, airborne remote sensing advantage is high resolution because the height is very minimum, no? It gives high resolution image when compared to the satellite remote sensing. Satellite remote sensing in the sense not to all the types of sensors. There are certain sensors, the resolution is very minimum when compared, which is minimum when compared to the airborne remote sensing images. If we want, there is a facility to get high resolutory satellite images also. But in normal general perspective, the airborne remote sensing images are having more resolution than the satellite images of certain sensors. The disadvantage is limited and low coverage area. This is the limited airplane coverage of the location is minimum, limited. It won't cover the large area. Whereas a satellite, it covers large area. And the second one is high cost. And mostly these type of operation we can carry out once. If you want to repeat, again the same process has to be repeat from the starting. Whereas if it is in a sensor, we can take n number of times. As long as sensor is working, we can take n number of repetitions. See here, what I'm speaking is here, airborne remote sensing covers a limited area, high cost, repetition may not be, what I can say is, may not expect in the frequency where the spaceborne remote sensing is having. Now, we'll go to the next topic. That is, of course, one more point we have here, and that is analog photography is capable of providing high spatial resolution. That's already I discussed. That's what I said to you. And these photographies and digital photographies, that means these photographies can edit by using certain computer applications. Whatever the image that is captured in your phone, you can edit. See, in a realistic terms, say, for suppose, if you, somehow you got a pic of so and so person. By seeing that pic, wow, what a handsome and beautiful, you may feel that. But when come to the realistic conditions, you may ask the same person, have you ever found, or else, have you ever seen this person? Did you understand what I'm speaking? You have an image, very beautiful image, very handsome image of one particular person. Unless he is not confirming that, you may not understand the pic belongs to him or her. What I'm speaking is, there is an option of edit for the images what you captured. By adopting the edit option, you can increase the resolution of the image. In realistic situations, the image is black or maybe dull resolutions, but you can enhance the color of the image also. It's not an image of person, maybe for any object. In realistic conditions, the image seems very dull. The image is dull. That it looks like an old one. But you can edit the same image and you can make the image, we can make that object as in a new one by using the techniques of camera and photography. That's what you mentioned here. There is, by using computer aiding, or as computer aids, we can edit the photographies. We can edit the images that we have taken by using cameras that are fixed to the airplanes and helicopters in the name of airborne remote sensing. Coming to that, spaceborne remote sensing. Here, spaceborne remote sensing in a sense. In the previous case, in the air, the cameras are working. Here from the space, it is working. Spaceborne remote sensing. The images are being taken, the images of the target are being taken by the sensors based on the instructions. See, a spaceborne remote sensing has the following advantages. The first one is it covers large area. we can repeat, we can take the repetitive images just in a fraction of seconds. See, quantitative measure of ground features using radiometrically calibrated sensors. Here, the measurement of an area is very easy. We can measure, if they see here, what that's what you wrote, quantitative measurement of ground features using radiometrically calibrated sensors. We can easily measure an area on the ground. See here, semi-automated computerized processing and analysis. When the data sent to the processing stations, we can adapt two technologies, that is completely digital and the other one is visual. Semi, and the second one is lower cost for unit area of coverage, because the satellite is already there and we can take the n number of pics. Whereas in airborne remote sensing, we need to send the flight, we need to arrange a flight or helicopter certain things, whatever required for this airborne remote sensing, which is more high when compared with the images that will take through the space-borne remote sensing. See here, the satellite image generally lower resolution, but there are certain sensors by name ICNOS 2. It gives the images at high resolution. Understand? See, airborne and space-borne remote sensing. See, retrieving information of target on the Earth by using cameras that are fixed to the airplanes or helicopters is called as helicopters or certain objects we have seen different platforms in the name of aerial platforms. When the images are being taken from those aerial platforms, we can call it as an airborne remote sensing. When the images are being taken by using sensors from the space, we can call it as space-borne remote sensing. And we already discussed about what are the advantages and disadvantages. In the airborne, the coverage area is minimum. Here, the coverage area is large. In airborne, cost effective. It is less cost. And there, the images are highly resoluted when compared with the certain satellite images. Here, of course, the problem is persists, but by using certain high resolution images, we can get the images at high resolution. The repetition is cost effective and work has to be done in airborne remote sensing. The repetition of the process is somewhat difficult when compared to take the repetition of images of the one particular desired location or the desired object. Now completely understood what is the difference between airborne and remote sensing, spaceborne remote sensing. Now this is what this is the airborne remote sensing and it is spaceborne remote sensing. Whatever the remote sensing, the image information has to be analyzed. This is spaceborne and it is airborne. And the same here, airborne and spaceborne. Okay? And next, we'll go to the very important topic. Keep in mind, very, very important topic. That is image data characteristics. You must remember the basic things of this image data this is the basic fundamental concept of fundamental first steps in remote sensing. Image data characteristics. See here, image of what? Image of anything, maybe image of object or image of a person, image of an area. The data in the sense it's in a plural word. It's in plural. Different characteristics, a set of set of instructions we can call based on the the need where we use that word. Image data characteristics. Characteristics, you and me know what is characteristics. Nothing but features. Nothing but what we can say is characteristics, points. Okay, what are the different types of characteristics of an image can be explained. Or as characteristics of an image in remote sensing holds all these characteristics. First and foremost thing is, see here, keep in mind, the image will be in this format. I told you in the beginning itself, the satellites will record the image of the target digitally. Digital in the sense like columns and row. This is a column and it is row. The image of any thing or its image of the target will be stored in the form of equally divided grid cells by name pixels. It is in a pixel. We can call it as a pixel. It holds an value. The image in remote sensing data has been divided into number of equally divided, equally quantified, equally divided space of columns and rows. Each column and rows, or else all the columns and the rows of an image, holds a number which is called as digital number. Which number? What is the, what is the range of this digital number? 0 to 255. In normal remote sensing applications, 8-bit application and 11-bit applications are there. For 8-bit resolution, the range is 0 to 255. For normal remote sensing applications, the image will be stored in the digital number range of 0 to 255. This zero indicates dull black. The 255 indicates high resolution. This is the peak. When you have in a television, sometimes you may try to adjust the color contrast. When you go to 0, you may not see anything, you may not visualize in your television. Even the same happens 255, there also sometimes you may not visualize based on the characteristic of the image. Did you understand? The image in remote sensing image will be stored in the form of equally divided cells of columns and rows, which we used to name them as pixels. P-I-X-E-L-S, pixels. And each pixel holds a digital number. That means the image is stored in the name of digital numbers, which are fixed in an equally divided grid cells called as pixel. This is in a grid. The other name is pixel. The range is 0 to 255. See here, the resolution of pixel is digitized and the same will be recorded as digital number. The range of digital number is 0 to 255. 0 represents low resolution and 255 represents high resolution. The address of pixel is two-dimensional and denoted by its rows and columns. The address of this pixel, I can say, where it is, where the 85 digital number is, here it is third column of first row. Third column of first row. See, the address of pixel is two-dimensional and denoted by its row and column. See here, we have a look here, pixel location 1 1. See, it is in column, this is column, and it is row 1 1. This is 1 in column direction, and this is also 1 in row direction, that is 170. 1 3. See here, this is column direction 1 and 3. See here, it's 1 1. It is in row direction. See here, 1, so 1 2. It is 1 and 2 is 238. 1 3. This is 1 and 3 is 85. Understand? Hope you understood. Okay. Now 1 1 170 and first column, of course, in the first row, second column 238. In this direction columns, in this direction rows. 1 1 in column direction 1 and row direction also 170. 1 2, this is 1 and 2 238. This is same in all these three. Coming to these two, 1 6, this is first, 6 is 0, and 2, this is 2 here, 1 is 68. That means all these ones are row numbers and 2 is, and 1 2 3 6 are column numbers. Here 2 is row number, 1 is column number. That means first is representing row number, first number, followed by column number. First row, first column is 170. First row, first column is 170. First row, second column is 238. Here 238. First row, third column is 85. First row, third column is 85. First row, sixth column is 0. Second row, the first numbers are representing here rows, and the second numbers are representing columns. Second, this is second row, column 1 is 68. Do you understand? Right. Next, moving to that, see here, this is what about the digital image data characteristics. 0 to 255 is the range, and all the image will be stored in the form of equally divided grid cells called as pixels, and the image resolution or else the information will be stored in the pixels with respect to the digital numbers. The range of digital numbers is 0 to 255. 0 is dull, 255 is high resolution. The address of pixel can be denoted with respect to the column and row. Of course, with row and column. See here, row is first and column is followed by parameter. Understand? And next, this is what about the image that we have taken from the satellite. And the information is like this. The information has to be decoded in the name of GIS. The output, this is what remote sensing, and from here GIS will be stored. The output of remote sensing is input to GIS. Next, the topic is digital image data storage formats. We have seen the characteristics of image data, and the followed one is digital image data storage. How the digital image is storing, how it is storing, what are the formats, how you are keeping your bags in your, how you are keeping your books in your bag. How you are keeping your sketch pencils in your box after using them. Are you simply keeping them, or are simply keeping with respect to the space provided in the colored pencil box? See, of course, it's just creating an awareness. Storage formats, how the image is being stored. See here, this is the image. And the same image, when you have a look over there here, the image will be stored in all the bands. Here, in this band, this band, this band, this band, X-ray, gamma, ultraviolet, visible, everywhere. And all these are the bands. The same image will be stored in the bands. See here, when you have a look here, bands, 1, 2, 3, 4 bands. In the electromagnetic spectrum, we have seen X band, gamma band, ultraviolet band, visible band. Here bands in this direction, 1, 2, 3, 4. Did you understand? Right. See here, the information is stored in all the bands of electromagnetic spectrum. How? In the form of digital numbers. These are the digital numbers. What is the range of digital number? 0 to 255. There are 3 types of digital format methods. One is BIP, first one. See here, band interleaved pixel method. What is the first one? Band interleaved pixel method. Band interleaved pixel method. What happening here? Let us have a look. These are the, see, for first band 1, Band 1, we are able to visualize what number holds in column direction as well as in row direction. See, in the first column of first row, 10. In the third, see, in the second column of second row of third column is 18 here. 8, see, it's in the second row of third column, the digital number is 18. Understand? But what about the underlying spectral bands, digital numbers, we are unable to visualize here. To teach you, I'm speaking, to give you, to impart the information. That is the reason the information of what we are unable to visualize kept here. Band 2, band 3, band 4. Again, for band 1 information we are visualizing because that is the top band. And the rest of the bands in this direction we are unable to visualize. For that, we kept band 2, band 3, band 4 of the band 4. See here, this is 90, where first column, first row, fifth column number is 90. Is there 90 here? 90. And second row, fifth column is 120. Is there? 120. And see here, third row, fifth column is 150. Fourth row, fifth column is 105. See here, able to visualize 100, 93, 93, 97, 97, 101, 101. Okay? For band 3, see here 103, 103. That means first row, fifth column is 103. Second row, fifth column is 150, 135, 130. See here 103, 90, 70, 120, 130. Okay, the same way here also. Why we are going through this band 2, band 3, band 4? Why not band 1? Band 1 is already here. We are able to visualize. But band 2, band 3, band 4, we are unable to hear. Visualize second row of second column. I can't visualize unless I go through this available data. Okay, now? Okay? Did you understand? Now, what is BIP method? Band interleaved pixel method. See here, in the first row of first column, it is 10. Okay. In the second row of, see here, in the second band of first row, first column is 20. So 20. Here, again, see, the third band, first row of third column is, see here. Understand? Did you understand? Did you following what I'm speaking? Are you following what I'm speaking here? Again, this is 10. How it 10 comes here? Because here in the first row, first column is 10. Why 20 comes here? First row, first column, band 2 is 20 pixels. Then, see here, for band 3, first row, first column is 120. So 120 here. And coming to fourth band, first row, first column is 210. So 210 here. Again, see here in the first row, first column is 10. So just to this band, we are unable to visualize here. So that's why we kept the numbers here. It is 20. Band 2, first row, first column is 20. So I kept here. Band 3, first row, first column is 120. So it is 120. Band 4, first row, first column is 210. I kept here. So for 4 bands, first pixel is over. Okay. Next is 15. First row, second column is 15. First row, second column is 15. So here, did you understand? 15 here. First row, second band, second column is 50. 50. For third band, first row, second column is 150. So 150. For fourth band, first row, so here 250. And I mean, the third column is 250. So 250. Again, fourth one is 20. So see here, first row, are you following? Just after this session, just rewind what I am speaking and have a look. Then you can easily understand. Okay, where we are here so far, up here, we are here. See, 50, 150, and 250. And again, the process will start. 70, 50, 100, 250. Again, the fourth column of first row is 21. Then 90, 90. And then 120, last 190. And then see here 21, fifth column, 21, 90 is here. 103 is here. 245 is here. That means the first row, first column of all the band, first row, all the 5 columns are stored. That means each pixel wise, first band, first row, all the columns are stored. Now second row, first column is 15. First column is 76. Third band, first column is 176. And similarly 156. So 156. And then fourth column. See here, fourth row, first column is 18. Band 2, fourth band 2, fourth row, first column is, see here, band 4, fourth row, first column is 200. So 200. Understand? See here, again. Band 4, it is band 4. Column is 1, 2, 3, 4. See, mean fourth row, the first column of fourth band is 200. So where we are keeping here, because we are ending with pixels. Now see here again, the fourth band, see the first band, fourth row, second column is 20. Did you understand? Again, these are the columns, 1, 2, 3, 4, 5 columns. These are rows, 1, 2, 3, 4 rows. These are bands, 1, 2, 3, 4. Now is here we are entering into the next stage, 18. Where this 18 is here, the fourth row, followed by 100, followed by 103, followed by 200, over. Then in the fourth row of second column is, see here, fourth row of second column is 20. Here 93. Here 90. Here 0. 2 columns are over. Fourth row of third column is 22. Here 97. Here 70. Here 123. Over. Now fourth row of fifth column. Now fourth row of, see here, fourth row of fifth column, how much? 25. So here 25. Here 105. Here 133. See here 133. And here 250. This is what about band interleaved pixel method. What is band interleaved pixel? Image stored in BIP format have the first pixel of for all bands in a sequential order. First pixel of first band of all spectral bands are in a sequential order, followed by the second pixel for all bands, followed by third pixel for all bands, etc. Interleaved up to the number of pixels. The BIP data organization can handle any number of bands. Whatever I discuss, you just have a replay for BIP. Then you can easily understand what is this BIP. Tomorrow we will discuss the following methods: band interleaved line method and band interleaved sequential method also. Again, the digital data format will be stored in the form of equally divided square shaped cells called as pixels. The information of the image will be stored in the form of digital numbers 0 to 255 its range. 0 is minimum, 255 is maximum. 0 represents dull, 255 represents high resolution. The address of pixel will be denoted with respect to rows and columns. Okay, that's what we discussed here. Understand? And see here, there are three types of digital data storage formats. One is band interleaved pixel method. The second one is band interleaved line method. Followed one is band sequential method. We'll discuss in the next class what is about BIL and what is about BSQ. If you have any doubts, please, and you are most welcome, you can contact me, whatever domain you feel comfort. Let us see what we discuss exclusively today. Apart from the previous topics, today we have seen the types of remote sensing: airborne remote sensing, spaceborne remote sensing, followed by image data characteristics, and we are discussing about digital data formats. In that, we discuss now the introduction part of image data, digital image data, of course, digital image, and we started regarding the storage formats, and we discussed about the first method of digital data formats. For today's session is BIP, we discussed. Okay, thank you, and we'll discuss the remaining parts in the next session. If you have any doubts, you contact me. Again, I'm from the beginning, I used to speak. I used to ask you if you have any doubts, you can contact me. Thank you.